Okay, it's question number 1. We have this function here, g of x, and g of x has that rule. And here it is graphed. If I graph memory initial, okay, pick this up, drag and drop. I can see that I reckon there's a stationary point of inflection here, and there's another inflection over here. Analysis, G-solve, inflection. That one there has a gradient of 0, and coming across there's another one there. So, okay, so I'm comfortable to say that I'm looking at x equals -1. If I was to take the second derivative, and I set that equal to 0 and solve for x, I get my two answers, -1 and 0, but I can see here that this is the only one that's got a stationary gradient. Find the coordinates of the local minimum graph. Okay, interactive, calculate, analysis, G-solve minimum, and that's going to be at 1/2. And so it's going to be the coordinates 1/2 and -27 on 16. The average rate of change, so it's average rate of change, which will be g of 2 minus g of 0 over 2 minus 0, which will give me, come up here, if I copy that, and maybe I define it. So I want $14. So that's the average rate of change between those. Find the equations of the tangents of the graph that have a gradient of 2. So I want the derivative of x and set it equal to -2. I take f of x and I take its derivative, and outside I make it equal to -2. I'm looking for those two answers. So that's at x equals 0 or x equals -3 on 2. So if I take f of x and I calculate the tangent line at x equals 0, I get y equals -2x minus 1. And if I take the tangent line at x equals -3 on 2, I get y equals -2x minus 43 on 16. Okay, so describe the transformations that graphs g to g of minus x minus 1. Therefore, the negative will reflection over the y-axis, and this will be -1, so a translation right, 1 unit. You could also go for the translate left 1 unit, and secondly, reflect over the y, and both of them are correct. Over the page, let a and b be positive real numbers such that the graph of this has a local minimum on the x-axis. So at the moment, it's got a local minimum here at y equals this, -27 on 16. So I want my minus 27 on 16 multiplied by A, then plus B, and I want it to equal 0. So I want the new coordinate to be on the x-axis. So the new y-ordinate is 0, and the old y-ordinate of minus 27 on 16. Therefore, B equals 27A on 16 will be what I'm looking for, B in terms of A. Or each real number, Okay, so if I take f of x and I make that A, I'll put that in a new line, make that K, and make that K, is that correct? And I define that. That's my new f of x, and it's going to be g, okay. Exactly one x-intercept. So if I want f of x to equal 0, and I solve that, I get the answers of x equals negative root k, x equals root k, and x equals minus k. Well, if k equals 0, that gives me one x-intercept, and it's at x equals 0. And the only other way is if k was negative less than 0, and that wouldn't exist, and that wouldn't exist, and that would give me my answer. So I want k less than or equal to 0, where I'll have exactly one x-intercept. Find the values of k for which the graph of this has only one stationary point. So if I take the derivative of this, calculate diff, simplify, oh beautiful. So I've got gk of x dash equaling 2x plus k, 2x squared plus kx minus k. So I'll get equal to 0 when x equals negative k. That's one of them. When k equals 0, that will be x equals 0, and that will be x equals 0. So I wish to include 0 again. Now, I will only have 1 when using the quadratic formula, when this in here is never equal, doesn't exist. So therefore I want the discriminant to be less than 0. So if I consider the discriminant of that term, so we're looking for the discriminant. Okay, the discriminant will equal b squared, k squared minus 4 times 2 times negative k. So the discriminant equals k squared plus 8k. So if I graph the discriminant against k, it's a parabola that goes through at negative 8 and 0, and I want it to be negative. So I want down here so that that doesn't exist, and this will give me my only solution. So that will be k between negative 8 and 0 will give a discriminant that is 0. Therefore, x equals negative k is the only stationary point, but I want to include 0, k equals 0. So I've got answers of k is an element of negative 8 not included to 0 included as being my answer to G part 2.